Sir, I'll introduce you first and then we'll start up. Uh, Keyur sir, am I audible?
Hello, Dr.
Good morning.
Devansh.
Good
Yes, you're
morning.
on. Good morning. How are you?
Sir, I'll introduce you. I'll share my screen first and then I'll request you to share your screen later on.
Okay. All right. Thank you.
Thank you, sir. Very good morning to all the participants and welcome back to the fifth day of Faculty Development Program organized by the Civil Engineering Department of IPS Academy Institute of Engineering and Sciences, Indore. And we have with us a very eminent person, Mr. Keyur Joshi. He is an environmental manager in Petrol Technica Environmental Services, Doha, Qatar. He is a graduate in environment sciences from Gujarat. He is a postgraduate in environmental pollution control from Middlesex University, London, UK. And he has gained 11 years of experience in environmental management and consents related work. He is an expert in environmental impact assessment studies, having experience in a wide variety of industrial projects like oil and gas, offshore and onshore explorations, metals, steel, copper, aluminium, gold, energy, cement, chloralkali, pharmaceuticals, waste processing, recycling industries, different types of incineration plants, waste oil recycling, battery recycling, surface coating industries, chrome, electroplating, galvanizing, powder coating, and so on. I welcome you, sir, on behalf of IPS Academy, and I'll hand over the screen and request you to please start with the session for today.
Thank you, Dr. Devanshi. Thank you for a very kind introduction. Right. Good
So
morning to all
please switch
participants.
on your camera as well, sir, please.
I think it is on. Yes, my camera is already on. Are you able to
I
see
can see
me?
you now. Thank you, sir, and good morning.
You can see me now?
Yes, sir, I can see you.
Okay, right. Good morning, everyone. Thank you, first of all, Dr. Devanshi and Mrs. Swasileka for inviting me to talk on this subject.
Thank you, sir.
Uh, uh, Dr. Devanshi has already given my introduction. So I'm working as an environmental manager in Petrol Technica Environmental Services. It's a consulting firm, environmental consulting firm, providing environmental services to regulators, industries, developers of the infrastructure projects, and our services basically include environmental impact assessment studies. So as a consultant, as a part of the environmental impact assessment studies, air impact analysis is one of the very critical component that uh, uh, we study. So before getting into the air dispersion modeling straight away, I would like you to take you uh, through a session overview, that what are all we going to cover in this session. So environmental impact assessment and air quality as one of its component. Air modeling, what is air dispersion modeling and what are the objectives, why is it done, what are the applications of air dispersion modeling, the different types of air models, uh, what kind of models are there and how it is used, the emission sources that are modeled, how to inventorize the emissions, uh, and then the different scenarios that we model. So as we get into details of the slides, and things will become more clear. As I've said that environmental impact assessment, it is basically a tool for the regulator to assess the environmental risk of a project. So whenever there's a new project, a new industry or new infrastructure projects, uh, these project activities are going to interact with different environmental components such as air, noise, soil and groundwater, wastewater generation, also socio-economic environment, and so on. When it comes to air, uh, the air impact assessment is done through air monitoring and also air dispersion modeling. When it comes to noise, the noise is also noise levels are measured and noise mapping is carried out. Similar with the soil and groundwater, we do soil monitoring and also perform the groundwater modeling. Similar with the waste and marine environment, where we perform hydrodynamic modeling to assess the impact of a project whenever a waste stream is discharged into an marine environment. What are their impact, how it is going to impact the marine fauna and the water quality, marine water quality. So as a part of this session, we are going to focus on the air quality and how we study air quality as a part of the development projects. So here we can see the overall concept. Basically, everybody is talking about the climate change, and the climate change is for real. And the components that brings this climate change is the change in the land use pattern, the meteorology, the weather is changing, the emissions that have been put into the air environment by the industries and by other human activities. So we can study the impact on these components through air model, and thereby we can assess the impact on the air quality and eventually the impact on health, the receptors. So all living beings on the earth are the receptors of any impact that would be there on the air quality. So when we look at the air pollution sources, there are various sources of air pollution. Some of them are natural, most of them are anthropogenic. So industries, vehicular pollution, infrastructure projects, power plants, industries, they all emit different kind of air pollutions. And these pollutants are added into the air environment. And if we name a few of them, the criteria pollutant as particulate pollution, which is often referred as particulate matter. Particulate matter, when we talk about the particulate matter with the size of 10 micron and below, which are called as suspended particulates that are suspended in the air, and they are so light that they remain suspended and they get into our breathing system through our nose. Other pollutants are there, such as gaseous pollutants. These pollutants are generated due to the combustion activity and the different activities. So these are the general air pollutants. Now we will get into the air dispersion modeling, which is a tool to assess the air quality of a project. So here we can see that this is the overall methodology, and here on the right side we can see this colorful image, which is basically an output of this air dispersion modeling exercise. So we will go through the details that how these emissions from the project are estimated, what are the site parameters, the metrology of that area, how it is fed into a model, and how the model is run, and this output concentration plots are generated, and how to interpret this plots and contribute to the air impact assessment with a meaningful conclusion. So basically, in air dispersion modeling is an exercise in which we can predict the pollutant concentration, different pollutant concentration at various locations of our interest around the project site. We can also identify that within an area which is the most polluting source in an area where in an industrial area where there are about hundreds of sources, and there's one particular source that is contributing the most. So through such models we are able to identify such sources and then take steps to control those emissions. We can also assess the source impact and frame the design control strategies. And when we talk about the prediction of this pollutant concentration, it gives a very meaningful ideas that how we can control emissions at the source in the media, and how to identify that we keep receptors away from that, or design facilities
So participants,
on
please
their
mute your phones.
So this is basically a Gaussian plume model that we are going to go through today, which is called AirMod. This is the basic algorithm. Hello.
Please put
Please put
yourself on
yourself
mute,
on
Mr.
mute, Mr.
Shokit.
Shokit.
Mute करो totally. Sorry for the
Hello.
disturbance, sir.
Yeah, no problem. I think now it's fine. Can you hear me?
Yes, sir, I can hear you clearly.
Okay. So, Gaussian plume model is a basic plume model that has been adopted by most of the model as well as the US EPA, United States Environmental Protection Agencies, to develop this model, and it considers the meteorology and also the different stability classes. Uh, Yes, different stability classes, and thereby uh, performing such modeling simulations. So it is basically an algorithm that is fed into the model, and once we insert data related to the source, meteorology, and the land use, based on this algorithms, we will get results that we can use it for the further analysis. Air dispersion modeling is a tool which is used for assessing the compliance when it comes to the air quality guidelines. There are different air quality guidelines set by US EPA. It is basically depends on the region and the government. So if I talk about here in Qatar, for particulate matter, the regulatory limit is 150 microgram per meter cube for PM10, and for PM2.5, we follow the US EPA criteria, which is 35 micrograms per meter cube. So similarly, different countries have different criteria, and these criteria are to be met for any development. So air dispersion modeling is useful for planning new facilities, determining the stack heights. Whenever there is a release of emission from the stacks, stack is basically a chimney in industries. When we see chimneys and the smoke coming out of these chimneys, using this tool we can predict that which way the plume from the chimney would travel, and in order to ensure that this pollutant disperse into the environment properly, so that concentration would not go beyond this criteria limits, we can identify the correct stack height using this model. We can also design the ambient air quality monitoring networks. Ambient air quality monitoring networks are basically stations that monitors the air that we breathe. for different pollutants, and this ambient air quality monitoring stations are to be strategically placed in an area where the highest concentrations of the pollutants are found, so that we get a representative measurement. Also, identifying the meaningful main contributors of this air pollution problems, uh, any specific industries or source that we can identify, and also develop a mitigation strategies. Mitigation strategy would involve, one of them is as increasing the stack height, uh, putting additional design mitigation such as control, using back filters. These are for the controls, changing the raw material, uh, and so on and so forth. It is also used for assessing the risk and accidental hazard, such as flaring. Flaring is considered as one of the emergency situation wherein the gases in an oil and gas plant are released all of a sudden, and these gases are toxic gases. So before they are directly being discharged into the air environment, they are necessarily to be burned off, and in such cases we need to study the emission scenario, and such models help us to study how these emissions would occur and in which direction they would disperse. There are different models that we use. One of the most common air dispersion model is air mode. Air mode is a steady state plume model that incorporates uh, the boundary layer and the turbulent structure. This is the most common model that is used for a project, and the project impact to be studied within a boundary of less than 50 kilometer. When it comes to studying the air quality impact beyond this 50 kilometers, like such a regional study is to be carried out that includes like more than 350 kilometers, CalPERF modeling system is used. CalPERF modeling system is also one of the advancement of the air mode modeling system, and the difference between these two is that the air mode basically treats the plume as a steady state plume, whereas CalPERF modeling system considers its a small puffs of smokes that travels, and through the path it changes the direction. So at each point, as the plume progresses to disperse, this CalPERF modeling system is able to predict the path of the plume. There are various other softwares such as offshore and coastal dispersion modeling softwares. These are used for specifically the offshore oil exploration platform, so that the plume behaviors onshore and offshore, it's completely different due to the meteorology, uh, and OCD predicts these emissions more accurately than any other models. Now, coming to the overall methodology of air dispersion modeling, we will go one by one. So initially, it's emission estimates. Once we have a project, we identify the different activities of this project, and for each activity, we are going to estimate the emissions. What kind of emissions are going to be there, whether it is going to be PM or there are going to be gaseous pollutants, some vapors, vents. After that, we look into the site parameter, in which location this site is, whether this site is in the valley area, or it is in the flat terrain, or is it outside somewhere in the city, in the or nearby a village, the location of the source, and the meteorological condition of that area. The meteorological condition of that area is very important when these details are very critical, because the entire dispersion pattern depends on the meteorological data such as wind speed, wind direction, temperature, mixing height, and then all these input parameters are fed into the model, and thereby we can obtain the analysis of contour plots, which we can utilize for the interpretation. So when we will see a case study in the following slides, these things will become more clear. The input data that are required for the EDM requires meteorological condition of the area, terrain, the undulation of the land surface. If it is a hilly area, the dispersion pattern would be different. If it is a flat terrain, it would be different. If it is a sea surface, it would be different. Then the emission source data are also very critical. We need to evaluate what would be the pollutant rate of emission and the mass of the emission that is being discharged into the air environment and their characteristics. And also, when we do this air dispersion modeling exercise, we will be able to identify that a project that is going to be there in future, what would be the load of the pollutants that it is going to put into the air environment in addition to the background concentration. So when we talk about background concentration, it is the current state of air before the project is implemented. We measure different pollutant concentration in the air, and that is called as a background baseline environment. Starting with the meteorological data would include wind velocity, wind direction, ambient temperature, pressure, rainfall, and thereby the model would calculate the different atmospheric stability classes. We can see here a windrow that shows that this is a windrow for the region of Doha, Qatar for 10 years of period. So in this region, we can see that the predominant wind direction is from northwest, and sometimes in considering the seasonal variation, we also see the second most predominant wind direction would be from northeast. And there are very less wind that is coming from the west and south. So thereby, if we see the map of Qatar, we would be able to see that most of the development that had occurred is on the east coast, and all these industrial settlements are either towards the north and the south. So this sort of tools can help us to identify the correct location to establish the industrial zones and the human settlements also. When we talk about the meteorological data, the model would require a historic data of long-term period that will vary from 1 year to 15 years. So when we talk about 15 years of meteorological data, there are various meteorological stations that are there, a grid of the meteorological stations, and also the satellite measured meteorological data is available. This meteorological data would include surface meteorological data as well as the upper air. As when we talk about the wind speed at the surface, due to the friction with the ground, it will be less. But as we go up and the elevation is higher, and the wind speed is also high. So we cannot only consider the surface wind, but we need to also consider the upper air data. These are the stability classes. We would quickly go through the stability classes. That what are they? The different pressure and temperature conditions would result into the different stability classes. These are there are 6 stability classes: very unstable, unstable, slightly unstable, neutral, slightly stable and stable. And we would not go much into detail for this, but what we can understand that the dispersion would depend on the combination of pressure and temperature and the stability classes that it would result into. Based on the stability classes, the smoke that is coming out of the chimney would behave differently. These are some of the example considering the stability classes, how the plume would react and disperse. So as we can see, looping, coning, fanning, fumigation, lofting, trapping, these are the different plume behaviors into different stability classes. What is the ideal situation is uh, the lofting, when the emissions would not come to the ground and affect human population, but where we can see the fumigation, the plume is not traveling far, and all this plume is coming to the ground surface, and this will impact the human population. Fanning is also one of the ideal scenario, and trapping is also results into the better dispersion. So after the meteorological data, the other details that we would require to feed in is the emission details. So firstly, we have to categorize the emissions, because as we see, we can see vehicular emissions, we can see emissions resulting from a chimney, we can see on a construction site loading, offloading activity wherein the material is being loaded, offloaded, and there are various type of sources. So we need to categorize the sources and identify that what is the pattern of emission. So all the discharge that happens through a point source, such as a diesel generator, or if there is a chimney in an industry, those are all called as point source. Even if there is a vent on a tank or large industrial tanks wherein this organic liquids are stored, so all this uh, point source emissions are considered in a specific category in the model, and there are specific details that are required to be fed in, such as the diameter of the point source, the exit velocity of the flue gas, so on and so forth. Coming to the area source is uh, an emission source wherein the emission could occur from a large area. If it could be a stockpile, it could be a large landfill wherein we see the emissions occurring through a big area, pond, lake. Similarly, with the line source, the emissions that are coming from the road sources, such as vehicular emissions, we can also predict the emissions from a moving source, such as trucks, vehicles, and there are specific information that are required to be fed in order to get the most accurate uh, results. Volume source would be one of the source wherein the emissions are from a building, wherein we can see that from the roof of the building some emissions are seen from an industrial facilities. So those are to be considered as volume sources. When we look at the emission species, so these are the main air pollutants of concern. There are other more, such as odor and all, but when we see the criteria pollutants, these are the initial six are the criteria pollutants, and other are the secondary pollutants: particulate matter, sulfur dioxide, nitrogen oxide, ozone, carbon monoxide.
Please put yourself on mute. Sifjan, sorry for the
Aromatic
disturbances.
hydrocarbons, acid gases, and heavy metals. So yes, this is the representation of the point sources and the details that we would require to feed in. When we see the point sources, they are flares, industrial chimneys, and the details that we will look at that needs to be obtained is stack height, stack diameter, the location coordinates, exit gas velocity, flow rate, base elevations, etc. um, there are certain phenomena that even in spite of the proper atmospheric condition, however, if there are structures that are in the nearby vicinity of a stack, as we can see here in this picture, there's a building, and just because of this building, the all the emissions are coming down, and this seems to be a very strange scenario, but what happens in this case is the wind flowing from here, it goes due to the obstruction of the building, it goes up, and the natural wind flow then after moving upwards it comes down, and when the wind comes down it also brings all the plume and the emissions in the plume also near the ground surface. So such phenomena are called as building downwash, and these are also to be studied in the model. Volume source include the industrial conveyor belts, roads, multiple vents, and when we study volume sources, we look at the dimensions of the sources, how long it is, how wide it is, and the particle size of the material that is being conveyed, and the location coordinates, and how effective this conveyor belts that are there to hold this material. There will be always some leakage that is sometimes it is seen, so we identify such leakages as also the source of the emission, and we can study it. Coming to the area source, here as we can see in this slide, in the photograph, that this stockpile is considered as an area source, wherein we can see that from a conveyor belt, this material is free falling into on a stockpile, and such sources are considered as an source area sources. And the details that we would look into is the height of the stockpile, the material that is being conveyed, and the particle size of the material, location coordinates, the activity rate, how many hours during the day this activity occurs, whether the belt and the stockpiles are covered or they are open. The main emission here is the wind that blows. It carries the dust, the material that is falling, it carries the particulates in this falling material. Then coming to the emission inventory. So the third thing is the emission inventory. We need to know that what would be the load of the emission from a future facility. So there are various methods that we can estimate these emissions. For the existing facility, direct sampling or the measurement is one way to estimate the emissions. In the case of chimneys, as we can see here in the photograph, there are stack monitoring activities that are carried out to accurately measure the level, the concentration of the pollutant in the stream, and thereby we can perform such calculations to estimate the overall load that is coming out of a particular source. When a facility is going to be there in the future, we can use the mass and material balance as to estimate the emission inventory. In this method, what we do is we study the process, we study the capacities of the equipment that are going to be there, the overall process, and we identify each activity wherein the material loss is identified, the emission source is there, and thereby we can identify what are the process losses where the material loss happens, and then these all losses are calculated and the emission inventory is developed. When it comes to the combustion sources, we can also use the fuel analysis, the sulfur content of the gas, and thereby with studying the fuel analysis, we can estimate emissions for sources such as diesel generator. Other than that, we can also follow the emission factors that are readily available. Environmental Protection Agency in US, they have developed this AP42 chapter, in which they have carried out numerous monitoring events in which they have measured multiple industry using the same technology, producing the same product, and thereby they have come up with some emission factors for specific activities. And these numbers can be directly taken into the model as emission factors. There are other tools such as tanks and Sengia. Tanks is basically to estimate the emissions from large tanks. Also the tanks from a fuel station, we can use this software to estimate the emission from the fuel station. Sometimes you must have observed that when you visit a fuel station facility, we can smell the petrol or the diesel at the facility. This is because of the loading and the breathing losses that occurs at the fuel station. Nowadays, there are technologies that are there, which is called as a vapor recovery system that can suck this vapor while loading the fuel into the tank, as well as when the big tankers comes to fill in the main storage, fuel storage. So we will be also seeing sometimes some small vents at the fuel station. All these emissions can be estimated with the tank software. And then there's a software called Sengia. The Sengia software is basically to estimate the greenhouse gases from oil and gas industries. So as I have said, Environmental Protection Agency have developed a detailed documents on each category sources, and based on the capacity of the equipment, the sources, the process, we can use these resources to evaluate and come up with a detailed emission inventory. So chapter 1 is for the combustion sources, that includes all kind of combustion engines, and then for solid waste disposal, and then so on. So there are about 15 chapters that are there for different kind of industries. So when we are estimating emissions from a meteorological industry, we can go to the chapter 12 and refer this detailed literature and extract the correct emission rates to perform such air dispersion modeling activities. So far we have just gone through the basics of the air dispersion modeling, and it was more of a theoretical part wherein we wanted to understand this terminology, and now we can go through a case study that gives us an idea that how this entire assessment process works. So before I get into the case study, if there's any specific questions I can address, or I'll go ahead. Any questions?
Are the participants having any question or doubt?
Yeah.
You can unmute yourself or you can even type in the
Uh,
chat box.
okay. Hello.
Hello.
Yes?
Hello. Hello. Am I audible?
Yes, you are audible. Please introduce yourself.
Yeah. My name is Sandeep. Actually, I wish to ask you, sir, that
Hello.
with
Yes,
this
Sandeep.
EPA if 42, the chapters included, does it have this values for emission rates for all the kinds of industries?
Yes, what they have done is they have categorized different industries. So when we talk about
Right,
the
sir.
metallurgical industries, so in metallurgical industries, they have a different chapters for steel industry, for aluminium, for copper, for steel industry, for the integrated steel industry, for the gold.
Right, sir.
So there are all different kind of industry that have been studied. So what US EPA have done, they have conducted numerous stack emission testing and uh, on-field measurement of such emissions, and thereby they could come up with some emission rates. Then when they say that there's a steel plant of about like 2 million tons per annum production capacity, So they come
Okay.
up with an emission rate that when you estimate emissions, uh, uh, you multiply the emission factor with the appropriate details, the capacity of the
Right.
plant, uh, the material that is being produced, and you can use this emission
Okay.
rates. So in my presentation, what I have done here is that I have included the links for each chapter, and all this
Okay, sir.
literature is available on USEPA website,
All
and
right.
it can be used.
So I had a specific question for like an area source, like for example, we have a landfill. Do they also provide emission rates for specific landfills, or it will be a general case in this sense?
Okay, there are various
Right.
ways again to estimate the emissions from the landfill. For landfill is considered to be an area source in which we
Right.
can also look into the USEPA documents and evaluate the emission rate considering the size of the landfill. So first of all, we
Okay.
need to identify that what kind of emission species would be there. Methane is one of the methane is one of the pollutant that is emitted from landfill side because of the underground process, and
Right.
these emissions are basically what USEPA have done. They have carried out the methane testing on the
Right.
different field sites, and the concentration of methane is measured, and then thereby they have come up with
Right.
this emission rates. So yes, this emission
Okay,
rates
sir.
for landfill facilities are available, and
Okay.
yes, you can refer to the USEPA.
Fine, sir. Thank you, sir. Thank you so much.
Thank you. Any more questions, or shall we proceed with the case study?
Yes, sir. Please, sir. Please proceed.
Okay. So what we have done here is I'm just taking one case study for a ready mix plant. Such assessments are done for various industries such as metal industries, oil and gas industries, then surface coating industries. But just to take a basic example of a ready mix plant, which is basically manufacturing of concrete. It's a quite simple process, and the pollutant that here we will focus on is particulate matter. So for those who knows where Qatar is, and for those who doesn't know, Qatar is a small country in Middle East, specifically in East Asia, and this is a map of Qatar. It's a very small country, and this box that we can see, we have a ready mix plant here in this area, and that is manufacturing concrete for the rapid development projects that are happening throughout the Qatar. So this is a basic process of a ready mix concrete plant, wherein the raw materials are taken from the stockpile and they are taken into the loading bin, and then it goes through a conveyor belt into the different silos, and based on the batch process and the specific ratios of this different materials, they are the dosage of each material is taken again on the conveyor, and then they are fed into the mixture, wherein this the water or the other admixtures are mixed, and then the concrete is manufactured and it is taken to the site for the manufacturing. So this is the basic process of concrete manufacturing, and now what we are going to do is that we are going to identify the point of emission sources in this process. So again, this is one of the extract from the US EPA, wherein they have studied this concrete ready mix plant very well, and based on the actual measurement of more than 250 such ready mix plant, they have come up with this emission factors. So as we've seen that it starts with the aggregate loading, unloading, and so all different kinds of aggregates are brought to the site, and when they are unloaded at the site, Due to the wind, there is a possibility of emission of particulate matter. When they are put into the stockpile, there is a possibility of emission of particulate matter. After that, they are taken from the stockpile to the elevated storage bin through conveyor belt. So that is again a source of the particulate matter. And at the same time, just the way as the aggregate, the cement, when the cement is unloaded, they are taken into the storage silo. So this silo are also a source of particulate matter emission. So here we can see that there are different points where the particulate emission, matter emission would occur. And now we are going to do the inventory and identify that what would be the exact load of this particulate that will be uh, emitted. So these are the side photographs where we can see the aggregate storage area. So where we can see here that the aggregate storage area is covered from three sides that breaks the wind and prevents the emission of wind blown emission. Here we can see the storage hoppers, and then here we can see the sand storage area. So what we did initially is in order to identify the so this was an existing facility and they wanted to go for an expansion. So for us the very first point was to study the current emission scenario. So we carried out ambient air quality monitoring using this equipment, which measures the different pollutants levels such as dust, particulate matter, and hydrogen emissions. Here are the links to various stations for year 2028.
At least I think now whatever is
And
Mr.
also,
Ghana, please mute yourself. Yeah, sorry
yes,
for the
and
disturbance again, sir.
no problem. And also, when we carried out this emission monitoring, we wanted to specifically understand that the emissions that are coming from this cement industry itself. So, what we did, the dust that we collected from from that area at six different locations, we analyzed that dust for the cementitious materials such as silica, calcium oxide, magnesium oxides, and the titanium dioxide and all, so that we could understand that this dust is not coming from any other source. It is specifically coming from the cement industry itself. So the plan for the cement industry was that they already had one present line that is manufacturing concrete by a dry mixture process, in which the aggregates are brought, put into the conveyor belt. It goes into the hopper, and from hopper it is directly fed into the mixture. And then there was one more line which was a wet line, in which the water and the ice is added, and then it is fed into the mixture. So there was one wet line and one dry line, and they wanted to go for a third line, and they were already facing some dust emission issues, and there were complaints from the nearby resident in the area that the dust is very high, and and they could see the dust on the clothes that are kept for drying outside, and in their houses and everywhere. So for this specific industry to go for another line, it was a very challenging scenario. So they asked us to perform this air quality assessment, in which we studied the present scenario of emissions and the future scenarios. When we conduct this ambient air quality monitoring, we measure the level of particulates, and as I mentioned earlier, the limit for the particulate levels in Qatar is 150 micrograms per meter cube, wherein when we see this 30 days of levels of particulates, they were observed to be very high. Specifically, when we see the trend, it is somewhere the average emissions were around 600 microgram per meter cube. So the current situation itself, the particulates in the air was way higher than the regulatory limits, and this was one of the concern of Ministry of Environment here. So we did the background air quality check, and then we started studying the process and identifying the point of emissions. So we could identify that the delivery of cement and the fly ash released during the silo unloading, that is one of the source. Delivery and stockpiling of the aggregates, transfer points where the transfer occurs from the conveyor belt to the hopper, from the hopper to the elevated mixture. So these are the points where the material transfer occurs, and thereby the emissions of particulate occurs. Also charging the truck mixture while loading, and also the vehicles and the equipment that are used on the site are the sources of emissions, including the diesel generator that was used for the electricity. So what we did is this is an aerial image of the facility. This is an aerial image of the facility, and we have marked all the sources. So these are the two lines that were there, where we can see this is the central mixture, this is the aggregate and sand transfer conveyors. This is the storage area that we have seen, that is covered by from three sides. This is the handling area, the sand storage area, and these are the paths that are followed by the loader on the site to take the sand from the sand storage area to the weighing hopper. So we identified this sources, and thereby we defined different area sources, line sources, and volume sources. So when we see here, central mixture is considered as a volume source. These conveyor belts are considered as line sources. The aggregate storage are the area sources, and the diesel generator is considered as a point source. And apart from that, there were different these red lines that you can see here are the silos, and whenever these silos are loaded and unloaded, there's a dust of cement and that comes out from the top, and that is also considered as a point source emission. There was also a truck parking outside, and this was not a paved surface. So when the trucks are moving on the unpaved surface, the tires, when they roll on this unpaved surface, the emissions of particulate matter occurs, and those are also considered to be the sources of emissions. Also the road, from the main paved road to the facility, the road was not paved, so this was also again an unpaved road from where this all the materials used to come to the site. So that is also considered as one of the sources of emission. And after considering all the sources, the emission inventory was carried out using the emission rates and the actual measurement that were carried out at the site using the stack monitoring and ambient air quality monitoring. So here we can see the particulate emission from the different sources and their load. Their loads are given in laps per hour, which is pounds per hour. So this is the activity rate, and when we multiply this with the number of hours of the facility operation, we can calculate the emission that occurs in the 24-hour period. So here we carried out scenario A, which is the present case scenario. in which we considered that to another sub scenario. One is the emergency scenario and one is the mitigated scenario. So when we talk about the emergency scenario, is the scenario when the pollution control system are not working effectively, and the pollution control systems are not able to suppress or collect this dust that is coming out of this process. And when we talk about the mitigated scenario, it is considering the engineering controls that are brought into the present scenario, when we try to control emissions at each transfer points and the silos and everywhere. What would be the effectiveness of this controls, and then we run the mitigated scenario. So after that, we looked into the possibility that what if both the lines are converted into the wet process line, then the dry process line, and then we run the scenario for which is called as the scenario B, and two sub scenarios in which one emergency and one mitigated scenario for the same sources. And after that, we wanted to define a study area, that when we do this assessment, how far we want to study this impact of this cement facility. So we created a study area of about 10 by 10 kilometer, and here we can see these green dots. These are the air sensitive receptors. So we identified all the residential places, in the hospitals, in the parks, where the human population is exposed to these emissions from this ready mix plant. So thereby we identified 23 different air sensitive receptors. So as we can see, the initial 6 to 10 were residential receptors, and these were the other receptors, which includes the farms and the hospital, the pump stations, and also and we performed also the ambient air quality monitoring at all these 23 monitoring locations. So after that, the model run was performed, and here we can see the results from this runs. In the present case scenario, when we run, this was the present case scenario when we did this study, and we could see that based on the model itself, the facility was contributing as high as more than 300 microgram per meter cube into the air. And then this emissions were traveling far. As we can see that as it goes far, the particulate settles, and the level comes down, but still in the very near vicinity, these levels were quite high. When we considered the controls over this, the engineering controls on these processes, we could understand this emissions levels are going low, and we could bring it down to 189 from 307. But still in this scenario, we could not bring down the concentrations within the regulatory limit, which is 150 microgram. So after that, we performed this scenario B. We considered that when the excuse me, when the engineering controls are not working and the air pollution controls are not working, and both the lines are wet mix line, we could see that the highest concentration that would go for the particulate matter within the 24-hour period would be 276 microgram per meter cube. And when the mitigation measures are taken, mitigation measures would include suppression of this dust by spraying water, sealing the transfer points, covering the conveyor belts in a way that the wind is not directly impacting this the material that is being made. Uh, so when we applied this mitigation measures effectiveness, we could see that the concentrations have come down as low as 7.35 micrograms per meter cube. So when these results were uh, looked into, we can see that in the case of scenario A and scenario 1 and scenario 2, one dry and one wet, the levels were high. With some controls, the levels came down to 188, but not all the way within the regulatory standards. But when both the mixtures were considered to be wet, and with the mitigated scenario, we could achieve the dust concentration of we could achieve the reduction into the incremental concentration for the dust as low as 7.34 micrograms. And based on this, the same thing is seen here in the chart. As we can see that this is nowhere comparable to these emissions, and we conveyed this model findings and recommendation to the Ministry of Environment, and the industry was asked to implement all these mitigations in order to bring this pollution of dust and thereby reducing the dust levels in the area. This included the areas that were not paved. They were supposed to be paved. They were supposed to check the leaks, and if there are leaks that happens, then they're required to contain these leaks. Sand and aggregate storage area that was open earlier, we had asked them to cover this, and to ensure that it is covered from the side where the predominant wind direction is considered while covering this area. The overhead storage bins are also asked to completely enclosed. The conveyor belt, which were exposed to the wind earlier, were asked to be covered and enclose it completely, so that the wind blown dust is emission would not occur from the conveyor belts. The dip tray system also installed, that any leak that occur from the conveyor belts we will be able to contain it into the drip trays, so that the material that has fall on the ground will not spread further. uh, Again, many other mitigations on the same lines to prevent all the leaks and the emissions from the vehicle equipments and the open areas were controlled. So yeah, this was, yes. So this was the case study from one of the ready mix Qatar plant, and how we did the air quality impact assessment, and thereby we could come up with this recommendation, and thereby reducing the level of dust in the area. So this was the case study, and now we'll go to the question answer session, and then if we have time available, we can go for a demo run with the software.
Are the participants having any doubts or queries?
Hello.
I think yes, yes. Please go ahead, Mr. Sandeep.
Yeah, this again. Yeah, I'm Sandeep again. Sir, I just wanted to ask whether this concentration, that is 7.34 micrograms per meter cube, in mitigated scenario, was this measurement performed inside the industry, or was it in the residential area or in the surrounding area?
Okay, so when we talk about these numbers, none of these numbers are concentration in the ambient air. These are the incremental concentration, the direct dust that is being emitted by the facility itself. So when we see the background concentration in an area where there's no influence of this cement industry, the levels were around 78 to 80. So when we put this 7.34, that will be an addition to this 80 micrograms per meter cube, taking it to 88.
Okay.
But
88. Okay.
yeah, but when we measured the levels of particulate in an area, that time we could identify that the average concentration was around 600, and the
Oh,
contribution from this cement plant itself was around 305.
okay.
Yes,
Okay, sir. Thank you so much.
thank you.
Yeah, that's okay. That's fine.
So anybody else who would like to ask?
Good afternoon, sir.
Yes,
Hello.
Neelam ma'am. Yes, ma'am. Please go
Yeah,
ahead.
yeah, yeah. Yeah. Good afternoon, sir. Sir, thank you for sharing such a valuable information with us. I have one question. Uh, uh, I have heard about carbon capture units in thermal power plants. So, can you explain something about that? And I also want to know, as you are talking about these modeling and measurement of particulate size and various gases, what are the direct tools or equipments which you use to measure all these things?
Uh, okay, sorry, but I could not get your question one. The question two was that how this, what are the equipments that were used to measure this ambient air quality
Yes,
pollutant? Yes.
yes.
Can you please repeat the question one?
Yes, sir, I have heard about carbon capturing units, like from the thermal power plants, coal-powered thermal power plants.
Yes.
There are emissions, right? So
Right.
to neutralize carbon, because we want to minimize greenhouse gases. So there are some methods I am hearing about that they are capturing this carbon from those emissions so that we can reduce GHG emissions. So I was actually I wanted to ask that also.
Right. Well, I can refer to one of the chloralkali facility that we studied here in Qatar,
Yes.
which is called as Gulf Chlorine, and their product was basically different chemicals in the chloralkali industry, including calcium chloride and all. And as a part of their mass balance, when we studied their mass balance, we could see that there was a lot of CO2 that was being emitted, and supposed to be, they were planning to discharge it.
Yes.
And we raised these points to them, and we recommended them to come up with a bottling facility in which they could recover this CO2 from the stream, and capture this CO2, which is used for different other industries as a raw material.
Yes.
And this has come up in one of the environmental condition by the ministry, and this industry was asked to install this CO2 scrubber, thereby capturing this CO2 in the stream, and setting up a bottling plant. And this CO2, which was one of the emission and liability, that was now, which is now one of the byproduct for them. So and this was converted into a commercial uh, 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 one way of earning money for the same facility, wherein their emissions for the CO2 were also reduced, and they could also make money out of this CO2 that was polluting environment. So yes, this there are many several uh, available technologies that can capture CO2, and uh, this pressurized CO2 can be used as raw material in many other industries, including this soft drink industries and many others. Yes.
Okay, sir.
And when we come to the question two, what are the equipment? So when we see the traditional equipment that were used, so if we talk about the PM, particulate matter, in India specifically, there are this equipment that are manufactured by Envirotech, and Ecotech and others, which they uses this high volume sampler, and the principle is to measure this dust levels by gravimetric method, in which one piece of filter paper is used, and there's a pump in the equipment which runs through for a limited period of considering the period that we want to measure for 24 hours and uh, 42 hours, and depending upon the duration that we want to measure, and then the dust collected on this filter is weighed, and the concentration of this particulates is calculated. So this was the traditional way of measuring these particulates in the air. What we use here now, we are also using the same technology. We have equipments from Envirotech. At the same time, now there are new equipments such as Aerocool AQM65, which is one of the equipment that we are using. Other than that, there's another equipment called HIM 6000, and these are the equipment that are fitted with the electrochemical sensors for gaseous pollutants, and for particulates, based on the particle refraction principle, these sensors are capable of sensing the level of dust in the air. So yes, these are the two equipments that we have used: Aerocol AQM 365, which is manufactured in New Zealand, and HIM 6000 hair scanner, which is manufactured in US.
Okay,
So these
thank you very
instruments,
much, sir.
sir, this is Devanshi. So these instruments measure the particulate matter directly.
Yes, it can measure the particulate matter directly for different fractions such as PM10 and PM2.5 both. And when we measure this particulate method with the gravimetric method, we only get one value for the entire duration, like 24-hour duration, we will only get one value. But with this
That
new
is the
equipment,
average value, I suppose.
yes, so a 24 hourly average value. But when we use this new equipments, they are able to provide the instantaneous value of particulates in the air. So when we measure for the duration of 24 hours, we can have one value for each minute. So yeah, so we can in fact analyze that which are the specific hours in a day when these emissions are going high, and higher elevated levels of dust are observed. So we can focus on the activities that are happening throughout those limited hours. And when we used such equipments for long period, for the baseline air quality monitoring projects, we could identify that when we look at the trends of such measurements, we can see the peak hours of traffic that is reflected in the trends. When we can see the weekdays and weekday and weekend trends, so we can see completely different trend for weekend, completely different trend for weekdays. Similarly for night and day during the festival seasons. Yeah, so there are many different ways we can interpret this data. When we get a very a detailed data, every minute data for 1 year of period, it's an amazing set of data.
So one more question: what are the gases which these instruments measure?
This instrument can measure sulfur dioxide, nitrogen oxides, carbon monoxide, ozone. It can also measure volatile organic compounds through PID sensor. It can also measure methane, but not at a very low range, but yes, it can also measure methane. So these are the pollutants that it can measure. But additionally, such equipments are also fitted with weather station, wherein they can measure the different parameters such as wind speed. They are fitted with the anemometer to measure the wind speed, wind direction, rainfall, uh, yes, and also the solar radiation.
Sir, Mr. Soumya has asked a question. Can these instruments measure bacterial population?
No, these equipments are basically electrochemical sensors, so they cannot measure the bacterial population. So what we do is when we carry out uh, the measurement for bacterial microbial parameters, uh, such as Legionella. These are specifically the bacteria that are found if found in food. It can cause many diseases. So we perform such measurement at hotel kitchens and indoor air quality and all. So these are basically, we use the petri dishes, and these dishes are exposed for a certain duration in that atmosphere, and then it is sent out for laboratory analysis, wherein the colonies, number of colonies are count. So yes, that's the method for microbial parameter measurement, but this equipment would not be able to yeah, measure the microbial parameters.
I hope Mr. Kiran Soumya's question is answered. So anybody else has any query, or we can proceed?
Hello.
Yes, please go
Hello.
ahead, Mr. Akash.
Yeah, sir, I just wanted to know that, sir, do you also generate datas? Like, do you sell them or do you, give it to some research organizations? That is my first query, sir. It's not a question. And second one is how, like, cost effective is for the research, scholars or the, young professionals, the equipments you are talking about and the all the associated cost. That is what I had. That's a sort of a query, sir.
Right. Thank you, Akash. When it comes to generation of the data, this data is basically a measured values of pollutants for each project, and what we do is we have these equipments that we use for specific projects. So we generate this data through a series of measurement, but these measurements are with certain objectives. So when we are carrying out such measurements for industrial projects, we do it for the different parameters. And when we do it for the construction projects, we do it for the different parameters. Again, we only measure at in the area of interest where the sensitive receptors are there. So we have a huge set of data, but this data are specifically used for the air quality impact assessment for that particular project only. Yes, so we have this data, and this data are specific to those industries, to those areas, and if required, it can be made available for the study purpose, and there's absolutely no issue for that. And when we talk about this equipments, sorry, what was the question regarding the equipments?
Like how cost effective is the equipments? Like you said, you can generate a lot of data, like from CO2, carbon monoxide, to a lot of things. You said a lot of there are a lot of indicators for which we can collect the data, and all those indicators are useful for research thing. So how cost effective is for the young scholars or the young professionals to
Yes.
go for those machines and equipments? That is what cost
Uh,
effectiveness is what I'm basically asking you.
Yes. So the same way that I have mentioned that these equipments are made in US, there are certain brands in India that are also manufacturing similar equipments that are very, very cost effective. The only limitation of this equipment is that it needs a very high maintenance, and in order to accurately measure these pollutants, it needs regular calibration. So certainly this equipment that I have mentioned are not very cost effective. They are quite an expensive equipment used for detailed studies.
Yes.
But uh, when we talk about such data, other equipments that are made by Indian manufacturer that are very cost effective, and it also does a very fantastic job. I think I do not have the details of the Indian manufacturers, but if required, I can pass it on to Dr. Devanshi
Okay.
later on, and then the same can be provided to you.
Yes, sir. That would be great. That would be great.
Sir, excuse me.
Yes, please.
Yes, Mr. Ashok, Dr. Ashok, sorry.
Sir, do we have such equipment which can be installed along the roadside on a traffic island and can display the pollutants or those SO2 CO2 parameters lively?
Yes. So what we do is that we when we are keeping this equipment for a long-term monitoring event, this equipments have they can be connected to the cloud, and there are applications that can be installed even on the cell phone. And once these equipments are placed there, it can be easily connected with the Bluetooth, and we can see the current the real-time measurement levels and the trend on your cell phone. So yes, it's possible. And there's a both the equipments, Aerocool and HIM 6000, it comes with a support that we can subscribe to their cloud services, wherein we can log in and see the actual data. And when we compare this equipments with the fixed ambient air quality stations, in comparison to the ambient air quality stations that are wherein we install these analyzers from Thermo Fisher and all, they are quite cost effective in comparison to the fixed ambient air quality monitoring stations. And we can see the real time measurement, and it can be displayed on a screen, or yes, wherever we want to, or it can be also given to the government agencies also, the links.
Hmm. So, Dr.
Should you
Ashok,
require
I
more
think your doubt
information
is
on this
clarified.
equipment? Should you require more information on this equipment, I can provide the same to Dr. Devanshi, and she can circulate the brochures and the detailed specs of the equipments.
Thank you so much, sir, for your so extensive efforts. Sir, I request you now to please give a short demo of the software which you had discussed.
Okay, so what we will do is we will have a very quick demo. The software that I'm going to use is an air mode view. So this air mode is basically an algorithm that has been based on the Gaussian plume model, and Lakes Environment in Canada and Trinity Consultant in US. They have developed their graphical interface for this models. And the graphical interface here that I'm using is from Lakes Environment. So it is basically an air mode view software based on the Gaussian plume air dispersion modeling theory. Uh, and this interface is developed by Lakes Environmental. They also provide the meteorological data and everything for this interface. So here what I have done is this is one of the area here in Qatar, which is called as the Pearl. So I'll just quickly open the place so that you will be able to see that what is the area that we are talking about. uh, so as you can see on my screen, this is Qatar, and this is the area which is called as the Pearl area. And the square that you see is the model domain that I have selected. So this is not a real scenario, but we are just for a demo purpose, we are going to consider one
Not
of the on this area.
so not able to see your screen.
Are you not able to see the screen? Okay. Can you see the screen now?
No, sir, it
Not
is
from my
not.
side. None of the conditions I think this.
Okay, let me see if it can. Can you see the screen now? Is my screen visible?
I fear not,
So,
sir. No, not from my side.
so the PPT is visible, but we cannot see
Yeah,
your screen. I think you should. Can you please share your screen,
refresh.
complete screen?
Okay.
Now it is visible, sir.
Now it is visible. Okay. All right. Yes. So this is the Air Mode View software, graphical interface developed by Lakes Environmental in Canada. They are associated with one of the company in Hyderabad. I think I forgot the name, but they often conduct the training courses in India in Hyderabad on air dispersion modeling. Okay, so what we are going to do, we are going to create a new case which is as a trial demo. So we are specifying the UTM zone. UTM zone is a part of so the region of Qatar falls into zone 39 north. We are taking one of the location from the Qatar as a reference point. So this is the x coordinate and the y coordinate. Then we can set the modeling domain. It could be up to 50 kilometers. So here I'm considering 5 kilometers as a modeling domain, and I'm just trying to check that whether it is falling. Yes, so it is coming here. So I'll just say okay and go back to the software and finish. So now our project is created for a study area of 5 kilometers. And I'll just quickly import the street map. So here we can see this is the study area. We can also import the satellite image. Yes, and if I can be more precise, this is the location for my office, and for an example we are considering uh, this is one of the shopping mall, and we are just creating source of a diesel generator on the roof of this shopping mall, and the base of the elevation is we are giving it as a so this is the source details that we are trying to feed in now. So base elevation will be about 20 meters, and the height of the release the stack of the chimney from the diesel generator, we are taking it as a 1.5 meter. Emission rate of the particulates from this chimney we are considering as 1 grams per second. The temperature we are considering as 240 degree centigrade, and the stack diameter as 0.1 meter. Diesel generator stacks are very narrow. Gas exit gas velocity is about 35 meter per second, and then it automatically calculates the gas exit flow rate. The DG as the source, and now we have this created a source which can see here. So we have created a source which is a small stack. Now, so once we create the project, we are now interested in creating the receptors. So we want to calculate the emission concentration of particulate matter in each box. So I'm not generating a very dense, because the dense receptor would take long time. So now when we see the grid here, we would be able to get an emission value in each of the grid box. And now I'll just process this. Then if there's any building nearby, we can specify the buildings in this area. We'll go to the meteorological files. I'll just take one of the meteorological data from So this is basically one of the meteorological data file that I have imported. With this, we can see the windrows for the meteorological data set. This includes a data set from 2014 to 2018. So we can see that the predominant wind direction is from northwest, and this is the wind speed and the wind frequency distribution. So this is the meteorological data that we have used. It is measured at 12. and we want to know that what will be the concentration for PM, so we can choose PM10 as one of the parameter. And when it comes to the averaging period, in the control pathway we can choose that we want to know that what would be the incremental concentration for 1 hourly average, 8 hourly average, 24 hourly average. Usually the standards are available for 1 hour and 24 hour. And then we go to the terrain, and we process the terrain from the WebGIS website. WebGIS website has data for uh, all regions and terrain data, detailed terrain data. This topographical data are directly downloaded from WebGIS with a resolution of 900 meter. So what we have utilized about 4 years of meteorological data. For 365 days, for 24 hours. So for each year, there is a data of 8,760 hours for 4 years. So about 35,000 hours of more than 35,000 hours of data is available, and it's being used in this demo. And we have created about
So,
441. Yes, so yes, please.
sir, how was the meteorological data set downloaded? Was it through GDAS?
No, this meteorological data set, there are various sources of this meteorological data. First is we can locally procure it from the meteorological department of Qatar. Similar is the
Right.
case with the meteorological center of India. This data are made available, and we
Okay.
can also procure this data from Lakes Environment, who's providing the processed upper air and surface meteorological data in
Okay.
MM5 format. So what we have
Okay.
done
All right,
here,
sir.
we can see this contours for the terrain. So wherever this sea surface is there, it shows 0, and we can see this on the land, this elevations are there. So we will go, we don't want to see the terrain contours, and also the receptors. Let's take it off. And then we go to the controls, and we want to see the plume animation. Okay, and then now we go to the run air mode. We check runs the details that there's no warning, the project is complete. So we are going to do the modeling for particulate matter for averaging period 1 hour, 8 hour and 24 hour for elevated terrain, and the source is one DG source uh, with about 41 receptors, so grid receptors. Meteorological data from the year 2014, and we will get values for 1 hour, 8 hour and 24 hour. And with that we'll run the software, and so now we can see that it is calculating for each day of 2014, now for 15, then for the year 2016, and so on till 2018. So for each day of meteorological data, these values will be calculated. This is a very simple demo for industrial projects and the infrastructure projects. There are a number of sources that are considered, where this runs may go up to the days what we have performed in just few minutes. Usually this runs may go up to few hours to few days, depending upon the complexity of these projects. So now we can see the results of this contour, and we can see that the highest concentration is coming as 649 microgram per meter cube. We can further break it down into different 20 levels, and yes, so here we can see that this is the source, and from the source the concentration is higher, and as it goes as it disperses, the concentrations are coming down. So this is just a demo purpose, just to show you that how the model is run and what kind of informations are fed into the model. We have run this model. So this is the highest concentration for 1 hour. For 8 hour, it is showing up to 220 microgram, and for 24 hours it shows 999 micrograms per meter cube. And once this model is run, we can also generate the reports for the result summary. And yeah, here we can see that if it is visible, let me just, yes. So when we see that we have used about 5 years of meteorological data, and the model is calculating the peak concentration as 650 at
Sir,
this
sir,
location.
this
So
is
we can see
Devanshi. Please
9.8.
enlarge it, sir. Sir,
Sorry.
the words are not clearly visible. Can you please enlarge it?
Okay. Okay. Magnifier. Yeah, is it visible now?
Yes, sir. It's clearly visible
Yes.
now.
So as we can see that for 1 hour, for 1 hour period, sorry, actually, I'm stuck. Yes, for the 1 hour averaging period, the peak concentration is observed as nearly 650 micrograms per meter cube, and this is the location where the peak concentration would be found, and it also calculates based on the meteorological data that for this peak concentration would be observed on the similar meteorological condition that was there during 9th of November 2018 at 5 a.m. in the morning. Similarly, for 8 hour, the peak concentration is observed at 220 microgram per meter cube, and the coordinates of the locations are given, and it will be observed with the meteorological conditions that were there on 5th of January 2018 at 8 o'clock in the morning. And for the 24 hours, it's 4th of July 2015 at 12 o'clock in the night time. So yes, so this is how the model calculates uh, the concentration at different points. Now we can also see, since we had created a grid, so we can see now at in the each grid box what would be the concentration. So as we go far, the concentrations are coming down, So this is basically called as a contour, and it is used for the analysis. So when we can also see, we can create the contours for the different seasons and different time of the day, and then the analysis and the interpretation is done in line with the objective of this study. So this is all about the demo, and if more information is required for a particular uh, industry or for air impact assessment that is done for a particular a project, please pass your queries to Dr. Devanshi, and I will be able to get back to you with the reports that are written for such case studies, and yes, provide you for a reading purpose. Any questions on the demo? If you want to do anything, if you want to ask anything.
Yes, sir. Again, Sandeep here.
Yes,
Yes,
please.
So
Mr.
these
Sandeep,
X
go
and
ahead.
Y coordinates, these X and Y are the coordinates in the directions of two-dimensional plane, right?
Yes.
So we are not considering this as a three-dimensional scenario, like Z axis is also not there.
When we see a contour on a map as an aerial image, it is not there. But when we see the reports here, we see that Z elevation here. Can you see
Right, sir.
here?
Right, right. I can see over there.
See that
Okay,
this concentration is observed at 5 meter, and both of them are at 3 meter. So yes, it is a 3D model, and when we want to see the contours into 3D also, we can see the view, it's a 3D view. I'm just trying to see if it comes. Yes. Okay. In order to see the 3D view, this needs to be processed appropriately, and this is a time consuming process.
okay.
Yes,
All right, sir. No issue.
this can be definitely seen into a 3D view, because since it
Yes,
is
yes.
a 3D model. Yes.
Okay, sir. Two short questions again. Uh,
Yes, please.
Yeah, regarding this source release parameters in the input values, if this was the case scenario for the DG set, right? So we put the values like emission, this emission rate and exit velocity and all this thing. Where all this measured with the help of stack monitoring kit.
It can, yes, it is available from the stack monitoring also. It is available from the supplier of the DG, who will also guarantee
Okay,
emissions, and we can
right.
also find out on the product sheet of the diesel generator what are the emission rate that would be. In addition, we can also estimate the emission rate from the uh, stack testing that is done for the similar capacity of diesel generator.
Okay, sir. So if it is a area source like a pond or a tank or a lagoon, like a wastewater treatment plant, in that
Yes.
case, how will we be calculating all these parameters?
Okay,
Like,
so what we can do is we can go and we can also create an area source. So where we
right.
can see here, this is an area source,
Okay.
and this is a circular area source. So if it is a pond, uh, we can create a circular area source like this, or the pond is not like a circular, and if it is a irregular shape, so we can also create a polygon and
Okay.
define the source. And once we create the source, uh, then we will be asked for the information to be included. So we include the base elevation, the release
Okay.
height, and then the emission rate. Now when it comes to the emission rate, this when we see this literature for the emission source, uh, for the point source it is in grams per second, but for the area sources, so we have to specify the emission in grams per second meter square. So this
Okay.
can be calculated once we feed these values here. The software will calculate for grams per second for the meter square, or when we can also use the same emission factor from the literature, or we can carry out an independent emission inventory
Okay,
for
okay.
this, and the emission can be fed here.
Okay, sir.
And then same simulation can be performed. Similar is the case with the line sources, where we have to specify. So these are for the line sources.
Okay, sir.
Yes, wherein we can specify a road. So here we can see the road, so that road can be considered as a source. And
Right.
once we create the source, then it will ask us for the inputs, and so they are different for different. So here you can see the vehicle, so we have to include all these details for the vehicle, that what is the height of the vehicle, what is the width of the vehicle, uh, uh, and whether it is a single lane road or double lane road. So yeah, there are a lot of information that goes into this software, and the more accurate information we include, our output would be more accurate. Yeah, so since it is
All
for
right.
a demo purpose, we would not be able to go
Right.
into yeah, it will be a
I
very
got
time
it.
consuming activity,
Right.
but yes, you can always
Right, sir.
write it on my email if there are any specific queries.
Right, sir. Sir, can you please tell me the name of that institute in Hyderabad providing this air mode training, if you remember?
Yes, just bear with me for a moment.
No, no issues.
The name of this organization is, I can share the contact details.
Sure, sir.
I do not have it really with me.
Not an issue, sir. It's okay.
So you get in touch with me, we will share the information with you.
Okay, ma'am. Okay, okay.
Laga System, yes. The name of the company is Laga System, LAGA,
Okay.
Laga System, and you can contact Dr. Sunkara Naidu.
Sunkara Naidu.
Yes, please.
Okay, sir. Thank you, sir. Thank you so much. It's really informative. Thank you so much.
Thank you. Any more questions?
So, is EPA providing the software for free, freely downloadable, or is it paid version? Air mode.
This air mode is a paid version,
Okay.
but when you attend the training course, they provide a demo version free for about 5 to 10 days period.
Okay. Okay, sir.
Yeah.
So I can see in the internet, like there are softwares like Breathe software or Invitrans, I think, Envirovare and all this. These are the
Yes.
consultancies.
Correct, but these are the detailed softwares, but there are open
Okay.
softwares that are available from Lakes Environment. So you can visit
Okay,
the
sir.
Lakes Environment website, where you can download the freewares, open software tools, which are screening models. So you
Right,
can
sir.
download Screen 3. You can also download WR Plot, which is a freeware for
Right, sir.
generating windroses using
Right, sir.
meteorological data.
So for training, this is freely available, right? In
Yes.
okay, Lakes environment only. Okay, sir. Thank you.
Anybody else who is having any doubt?
Sir, madam, I have one doubt. Means just
Yeah, please go ahead,
I
ma'am.
want to know. Sir, is Pollution Control Board of India using the same technologies? I just a query, means what are the tools they are using to determine the pollution levels in various cities?
Right. In fact, we are we have institutes involved from India who are also involved with us for major projects to assess air quality in Qatar. In India, organizations like Central Pollution Control Board and all, they are getting such impact assessment studies done through institutes like IIT Kanpur. They are very well equipped with such softwares, and in India also many consultants, they are performing air dispersion modeling using softwares like Air Mode and Kelpov. So yes, this is also a requirement in India. I think the category A projects, those are being handled by central Ministry of Environment and Forest. They are asking for air quality impact assessment done through softwares like Air Mode and all. Earlier they were using ISCST3 as one of the software, but nowadays Air Mode is more preferred as it is a better option. And yes, there are many consultants in India who are also using the same software for such studies. But I think in India, for medium scale projects, this such software tools are not used. But certainly for category A projects, where I was when I was in SR working with SR Steel Industries, they were going for expansion projects for integrated steel industry, and yes, we did carry out impact assessment using the same software.
Wow, sir. Thank you so much, sir.
Yeah, thank you.
Our participants, any of the participants want to ask any questions, or I suppose, sir, you have given such a nice and well explained overview about the air quality modeling that I don't think anybody has any doubt further. But still, if anybody has any doubts or would like to have some questions answered, you can get in touch with us again.
Perfect.
With this, we come to the end of the 1 week online faculty development program organized by the Civil Engineering Department of IPS Academy, Institute of Engineering and Sciences, Indore. I would like to grab this opportunity to thank the expert for today, Mr. Keyur Joshi, for devoting his precious time and explaining in such a wonderful way regarding the air quality modeling and minor aspects of all the issues related to it. And along with that, I would also like to thank the chairman of our organization, Architect Achal Chaudhary sir, the principal of our Institute of Engineering and Science, Dr. Archana Kirti Chaudhary ma'am, Dr. Kirti Chaudhary sir, the head of the Department of Civil Engineering, Swatilika Guha ma'am, for giving me an opportunity to coordinate for the faculty development program. A special thanks to the experts, Mr. Keyur Joshi, Dr. Bhagyashree, Dr. Ratnakumar, Mr. Kundan, and Mr. Rakesh for sharing the expertise with us. Also, I would like to appreciate Mr. Pratyush Motwani sir for the technical assistance and untiring support he has been providing me throughout the faculty development program. All the supporting staff on the screen, off the screen, the participants and the parent organizations, and my parents, my family members, faculties of Civil Engineering Department and IPS Academy for supporting the program. A special note of appreciation and gratitude to Mr. Amit Maurya for making the arrangements at Qatar, and all the visible and invisible contributors for making this faculty development program a success. Now I request Swatilika Guha ma'am, the head of Civil Engineering Department, IPS Academy, Institute of Engineering and Sciences, to address the audience, please.
Good afternoon, all the dignitaries from various reputed institutes from all over the nation and outside India. In these tough times of unprecedented pandemic caused by COVID-19, we are pleased to able to organize this FDP on Eco Enviro Sustainability under the banner of TechCube 3. I would like to thank all the participants for their participation and also congratulate them for the successful completion of the course. I hope with the help of this FDP, we were able to provide you a platform to connect with experts like Dr. Bhagyashri and Dr. Rakesh from NEERI, Dr. Ratnakar from IECRS, Mr. Kundan from GIZ, Mr. Keyur Joshi from Petrol Technica Environmental Services. I also bestow my hearty thanks to all the experts for their valuable time and lectures on behalf of Civil Engineering Department family. I would like to thank RGPV Bhopal for providing us the platform of TechCube 3 and hope in future we'll again get associated with each other in person after this pandemic is over. Thank you very much.
The feedback link is provided to the participants in the chat box. It will also be shared in the groups. Please fill it carefully because the name in certificate will be displayed according to that. And I thank you, Mr. Keyur Joshi, again for devoting your time and such a wonderful and elaborate session. We thank you and we hope to be in touch for future endeavors again. Thank you, sir.
Yes,